Hi guys, welcome again. In my previous video, I showed you how to derive the three basic equations of motion. But in this video, I'll be showing you how to solve rectilinear motion problems using the equations of motion. Let's begin. Here we have a problem that says that a car traveling at 52 meters per second slows down uniformly to a velocity of 30 meters per second. A says, how long does it take to cover a distance of 60 meters? And B says, what is the deceleration? Let's begin. First, let's analyze the question. The problem here. It says a car is traveling at 52 meters per second and slows down uniformly with a velocity of 30 meters per second. So you have two velocities. So let's begin with solution. Let's begin with A. Let's begin with A. Okay. A is asking for the time. The time this car will travel was 60 meters. So the initial velocity is 53 meters per second, and the final velocity is 30 meters per second. So our initial velocity is v naught, and the final velocity will be v, which is 30 meters per second. Okay. The question is, how long will it take the car to travel a distance of 60 meters? So S is the distance, 60 meters. The time is unknown. That is what we want to find this problem. Let's begin. To solve this, in this problem, we have two velocities: the initial velocity and the final velocity. And the car is moving with a uniform acceleration. So therefore, the distance will be equal to the average velocity multiplied by the time the car will take to cover the distance of 60 meters. So the distance is S equal average velocity, V represents the average velocity multiplied by the time. And we know the average velocity is the initial velocity plus the final velocity over 2. So S is equal to average velocity is V naught plus V over 2. That's the average of the two velocities multiplied by T. And here we have S, the distance is 60 meters. So 60 meters is equal to the initial velocity is 52 meters per second. The final is 30 over 2 meters per second by T. So 60 meters is equal to 52 plus 60. 52 plus 30 is 82, 3 over 2 is 41. 41 meters per second. T. So we've seen the find T value for both sides equation about 41 meters per second. 41 meters per second. So 41 cancels 41. Whatever T is equal to. So 60 divided 41. Calculator. It gives us 1.463. So the time is 1.463 seconds. So this is the time the car will take to cover the distance of 60 meters. And the next question is asking, what is the deceleration? B is asking for deceleration. Let's call it D. Okay. We know that acceleration is the increase in velocity with respect to time, but deceleration is a decrease in velocity with respect to time. So looking or analyzing this motion, the car started with the initial velocity of 52 meters per second. It little slowed down to 30 meters per second. So this car, it decelerated. It decelerated because the velocity reduced from 52 to 30. And the deceleration is a negative acceleration. So the deceleration of a moving object will be equal to the initial velocity minus the final velocity over the time. So the D is equal to the initial velocity is 52 meters per second. The final velocity is 30 meters per second. or the time is 1.46 seconds. So 52 minus 30 gives us 22 meters per second, or over 1.46 seconds. So let's do our calculation. 22 divide 1.463. I'm sorry, this should be 3. 1.643 seconds. So it gives us 15.04. 15.04. So we see our deceleration is equal to 15.04 meters per second square. So this is how we found deceleration using this analysis. I mean using in motion problem like this. So let's go to the question. The question asks us to find the time the car takes to cover the distance of 60 meters. So from our computation, we call the time to be 1.46 seconds, 1.463 seconds. And to find the deceleration, we need the time. Because the deceleration is the initial velocity minus the final velocity over the time. So the initial velocity was 52 meters per second. The final velocity was 30 meters per second. The time we call was 1.463 seconds. So mathematically, our deceleration is 15.04 meters per second square. So let's look at another problem using this analysis. Okay. The next problem says a body starting from rest travels for 30 seconds. Determine the final velocity attained for covering a distance of 75 meters. So let's analyze the motion. So let's begin by setting our data. Solution. Data. Okay. The body is starting from rest. So whenever a body starts from rest, the initial velocity becomes 0 automatically. So if you know, because 0, which is the initial velocity. Determine the final velocity attained. So we are asked to find v. So v is unknown. Attained for covering a distance of 75 meters. So s, which the distance is 75 meters. Okay. So in one of my previous videos, we derived 3 basic equations of motions, and they are v equals v naught plus at, s equals v naught t plus 1 over 2 at square, v square equals v naught square plus 2as, where v is the final velocity, v naught is the initial velocity, s as acceleration in t is the time. In this equation, s is the distance, v naught is the initial velocity, t is the time, is acceleration. In the third equation, v is the final velocity, v naught is the initial velocity, is acceleration, s is the distance. Okay. And so first, here we have 3 variables, v naught, and s. So ask ourselves, which equation really or suit these variables? Let's begin by solving let's begin by using the first equation that says v equals v naught plus at. And again, they told us that, from the problem, we know that the initial velocity is 0. And the time is 30 seconds, rather. 30 seconds. Time is 30 seconds. We know that the initial velocity is 0. So that will v is equal to, so yes, you have 80. So v is equal to, we don't know a or no t value. Is unknown and t is 30 seconds. So a 30 seconds. Okay. So let's keep this value. Then let's use the second equation that says s equal to v naught t plus 1 over 2 at square. S is equal to v naught t plus 1 over 2 at square. Where is the distance travel? This v naught is initial velocity, but the problem is that v naught is 0. V naught is 0. So the s is equal to 1 over 2 at square. Okay. We know s value is 75 meters. 75 meters is equal to 1 over 2a. A is unknown and t is 30 seconds. R square, so 75 meters equal to half of A. 30 square case or 900. So 900 square second. So 75 meters equal to half of 900 is 450. 450 second square multiplied by A. So to find A value, to propose how to equation by 450 second square. We are doing this because we want to get A value. So we won't have A value to get a final velocity will become very easy for us. We'll have A times 30 seconds. So A value will be equal to 75 divided by 450. Let's see what will give us. 75 divided 450. It gives us 0.117. 0.17 meter per second square. This is acceleration. With the aid of the acceleration, we can find our final velocity. And we'll come back to the question as we'll come back here because here we have V is equal to A times 30 seconds. So V is equal to, we know A value is 0.17 meter per second square. Times 30 seconds. So V is now equal to 0.17 times 30, 0.17 times 30, it gives us 5.1 meter per second. So this is the final velocity. Thanks for watching this video. This video is intended mainly for WAS safety students. Please don't forget to subscribe to my channel for more videos. Thank you.